Hello, everybody. This is Mr. Tam back with another math episode, this time for Secondary 4 CST and Science Option Math. Now, this is a topic that both courses do share, so please feel free to share this video with everybody that you know that's in Secondary 4. So, one of the topics that you guys are learning, either have done so in the past month or before that, is angles and how they relate to one another. So I thought I'd just do a quick little video on a few terms that one may need to remember. So essentially you have, whenever you're talking about a 90-degree angle, something that is called a complementary angle. Complementary angle. And whenever you're talking about a straight line where two angles add up to give you 180, this is what we call a supplementary angle. Supplementary. And that's all I wanted to really review with you in terms of those two types of angles. What's more interesting is something we call parallel lines. And when you have a line that essentially cuts them into sections. So let's imagine here that I literally drew for you guys a set of perfectly parallel lines. We know my drawing skills are not the best, but hopefully that's parallel enough for you guys that you guys know what's going on. Now, the additional line that I've drawn right here is what we call a transversal line. So this is what I would like to do. I'd just like to make sure that you know the name of this line, transversal. And to indicate that, you know, even though they may not be perfectly drawn parallel, but the intentions is that they are drawn parallel, is that I will make two arrows on each line to indicate that they are running next to each other, much like train tracks. So the first type of angle I'd like to talk to you guys about are these angles right here. So I'm going to label this angle 1, and I'm going to label this angle 2. I'm also going to go ahead and label this angle 3, and this one right here, angle 4. So if you notice, those two lines are parallel to one another, the ones with the arrows, and they remind me kind of like train tracks. Now you can imagine, you know, running on, you know, the train tracks, you have the angles I just labeled on the outside of the train track. So you have to imagine that the train tracks that I'm talking about are this line and this line. So that being said, since those angles are on the outside of those train tracks, those angles, we'll call them alternate exterior angles. Okay, so I'm going to do a little symbol like that. So alternate exterior basically means that angle 1 is congruent. This little symbol here means they're the same as angle 2, and that angle 3 is the same or congruent to angle 4. So what that means is if I'm referring to this angle right here, I know that it should be exactly the same as this one right here. Much like angle 3 is also on the exterior of the train tracks, but on the alternate side of that transversal line. So exterior for being on the outside of the train tracks, and alternate for being on the opposite sides of that transversal line. So if we have exterior angles, it means at some point we're going to have interior angles as well. Let's try to change this up with a slightly different color. So I'm going to label this angle right here angle 5, and I'm going to label this angle here 6, this one here to be 7, and this one here to be 8. So I have my alternate interior angles because they are all inside the train tracks. And these are found to be angle 5 being congruent to angle 6, much like angle 7 is congruent to angle 8. So, perfect. We have just another set that we need to talk about. And those, of course, are what we call corresponding angles. I'm going to do this just in a different color. Corresponding angles basically say to yourself, you have to say to yourself, if I look at this as a whole box and I look at this as a whole box, which angles must match up to each other? So, corresponding angles are the following. If I look at angle 1, it's actually corresponding to angle 8. So this one related to this one. And then if I were to look at angle, let's say 3, I know that it's congruent to angle 6 because they are corresponding to one another. So I'm going to put 2 dots for you guys here and 2 dots for you guys here. So these ones are going to be my 2 dots. Then I have my angle 7 right here, 2, 3. I'm going to call that 3 dots, is corresponding to angle 2. So I'm going to say angle 7 is corresponding to angle 2, therefore congruent. So this is my 1, 2, 3. I'm going to separate it so that you guys don't get confused here. And last but not least, 1, 2, 3, 4. 1, 2, 3, 4. That angle 5 is indeed corresponding to angle 4. One last thing I should mention, though, is that any line, and it can even be applied on those parallel lines I just finished with you guys. Let's do this one in pink here. That any 2 lines that bisect, not bisect, but that they cross each other, 2 transversal lines where angles are across from each other, like this angle and this angle, we call these vertically opposite angles, and therefore they must also be congruent. Much like these 2 angles are congruent to the other angle across from it. So those are vertically opposite as well. And I thought I should finish just by mentioning really quickly that our friend the triangle always has interior angles that add up to 180. So angle 1, angle 2, angle 3. 1 plus 2 plus 3 always equal 180. And any quadrilateral or 4-sided figure, be it a trapezoid, be it a parallelogram or a rhombus or a square or a rectangle, those 4 angles that we add together, be it the same or not, whether it's a regular shape or not, they all must add up to a grand total of, drum roll please, double that of a triangle, which is 360. So this was my nice quick little review. I'm hoping this helped you guys out. Keep safe. I know these are tough times. Keep busy. Hopefully this will inspire you to practice a little more math while we have the time. So this is Mr. Tam signing off, and I will see you in the next episode. Bye.